The interstellar comet just passed the sun. Everyone wants to know when they can see it. Mid-November, they say. Morning sky, they promise. But what does that actually mean? When does it clear the solar glare? What equipment do you need? Where do you point your telescope? And why is everyone suddenly talking about nickel vapor and 7 billion-year-old ice? 3I Atlas, the third interstellar object ever caught entering our solar system. Discovered July 1st, 2025. Atlas telescope in Rio Hurtado, Chile. 1 pixel among millions. Moving wrong. Too fast. Hyperbolic trajectory confirmed within 48 hours. Not bound to our sun. Just passing through from another star system entirely. 2 previous visitors. 1I Oumuamua in 2017. 2I Borisov in 2019. Now this. Third chance in 8 years to study something that formed around a completely different star billions of years ago and traveled the void between systems before stumbling into our neighborhood by pure cosmic accident. July 1st. Discovery Day. The comet sat 420 million miles from Earth, magnitude at 17.5, invisible to anything except big survey telescopes, already active, already venting gas, water vapor, carbon dioxide, carbon monoxide, coma forming, tail growing. All of this at 6.4 astronomical units from the sun, where temperatures should keep most ice locked solid. That early activity told astronomers something. This comet runs hot, not temperature hot, composition hot, loaded with volatiles that sublimate far from the sun. Carbon dioxide ice transitions straight to gas at minus 100 degrees Celsius. Much easier than water ice. The dominance of carbon dioxide over water makes 3I Atlas unusual, even among the rare interstellar visitors. James Webb Space Telescope locked onto it. August 6th. Near infrared spectrograph, the data came back strange. Carbon dioxide emission lines dominated everything. Water was there, but secondary. Carbon monoxide present. Carbonyl sulfide detected. The ratio was wrong. Solar system comets typically show water as the primary volatile. 3I Atlas flipped that script. Very large telescope in Chile. Multiple observation runs through July and August. Spectrographs aimed at the coma. Team led by Rohan Rahat-Gaonkar at Instituto de Astrofísica Pontificia, Universidad Católica de Chile. They found nickel, atomic nickel vapor, glowing in the comet's atmosphere at 3.81 astronomical units from the sun, nearly 4 times Earth's distance from the sun. Nickel vaporizes at 1,453 degrees Celsius normally. The comet's surface temperature at that distance measured maybe negative 100 degrees. Physics doesn't work that way, unless the nickel isn't pure metal. Hypothesis centers on nickel tetracarbonyl, volatile organometallic compound. 4 carbon monoxide molecules bound to 1 nickel atom. Breaks apart under ultraviolet light from the sun, releasing free nickel atoms at much lower temperatures than pure metal would require. If you value documented astronomy and deep space chemistry like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from NASA's official 3I Atlas mission page, last updated November 2025. Guys. The European Space Agency's detailed FAQ published October 2025, peer-reviewed spectroscopic analysis from the Very Large Telescope team published in preprint on ARXM, September 2025, and real-time ephemeris data from JPL Horizons and the SkyLive orbital tracking, updated November 5th, 2025. These aren't secondary news aggregators, these are primary observational sources and space agency documentation. Now back to the information. The comet moved inward. August brought it through Ophiuchus, Scorpius, Libra, magnitude dropping from 16 to 14, still telescope only, still faint, but brightening as solar distance decreased. September passed with the comet stuck in Libra, magnitude 13 reached. James Clerk. Maxwell Telescope observed it. September 7th, hydrogen cyanide production rate measured at 1.5 plus or minus 0.5 times 10 to the 25th molecules per second. 1 week later, September 14th, that rate tripled. 4.5 plus or minus 1.9 times 10 to the 25th molecules per second. 2 kilograms of hydrogen cyanide per second venting into space. Hubble kept watching. July 21st, images constrained the nucleus diameter. Somewhere between 440 meters and 5.6 kilometers, most likely under 1 kilometer. Small for a comet. The teardrop-shaped coma showed clear in Hubble's optics. Dust and gas streaming back from the nucleus as solar heating drove sublimation. October 3rd, closest approach to Mars. 18 million miles, 29 million kilometers, 0.19 astronomical units. Every spacecraft at Mars got tasked to observe ExoMars Trace Gas Orbiter, Mars Express, Mars Reconnaissance Orbiter. Though NASA's shutdown blocked that data release, TGO's Cassis camera captured images. October 3rd, when the comet sat 20 million miles from the spacecraft, a slightly fuzzy white dot, instruments designed for Mars's bright surface struggled with a faint comet orders of magnitude farther and dimmer. Mars Express tried, but couldn't resolve it. Lower exposure time. Target too faint. October moved fast. The comet's solar elongation decreased. Angular separation from the sun and Earth's sky narrowed. By October 1st, it dropped below 30 degrees. Observers in equatorial regions caught it low after sunset. Window closing. October 6th passed. Ground-based telescopes in most locations lost sight of it completely. October 21st, solar conjunction. 3I Atlas positioned directly behind the sun from Earth's perspective. 12.8 degrees solar elongation. Impossible for ground observers. Space-based assets took over. GOES 19 weather satellite tracked it. SOHO spacecraft observed. Stereo. I kept eyes on it. Punch satellite constellation recorded data, all designed to see objects near the sun. All confirmed the comet remained on trajectory. October 29th, perihelion, closest point to the sun, 1.36 astronomical units, 203 million kilometers, 126 million miles, right between Earth's orbit and Mars's orbit. Never closer than that. The comet reached peak solar heating, 770 watts per square meter bathing the nucleus, sublimation rates maximized. Gas and dust production peaked. Space-based coronagraphs watched it happen. Astronomers Chi-Cheng Jiang at Lowell Observatory and Carl Battams at U.S. Naval Research Laboratory analyzed the data. They published on Archive. The comet brightened dramatically during perihelion passage. Originally predicted magnitude 11.5. Space-based observations suggested it hit magnitude 9, 2.5 magnitudes brighter, 25 times more luminous than expected. Driven by visible gas emissions, the team predicted 3 in Scuitula. I-Atlas would emerge from solar conjunction considerably brighter than it entered. That matters for November. The brightness surge means better viewing, easier detection. Smaller telescopes might catch it. October 30th, Halloween Eve, Venus passed nearby. 3 to I-Atlas slipped just 0.8 degrees northeast of Venus that morning. Both objects sat 5 degrees above the horizon 1 hour before sunrise. Deep in twilight, impossible viewing geometry. Venus blazed at magnitude minus 3.9. The comet glowed around magnitude 9 or 10, overwhelmed by Venus, drowned by twilight, positioned too low. But the geometry shifts fast after perihelion. The comet's hyperbolic orbit carries it back across the ecliptic plane heading outward. Solar elongation increases. Distance from the sun's glare grows. By November 3rd, it passed Venus at 0.65 astronomical units. 97 million kilometers, too close to the sun still for ground observation. November 9th, the eastern pre-dawn sky, latitude 40 degrees north. 3I Atlas climbs to 10 degrees altitude just before dawn. First potential ground-based sighting for equipped observers. Waning gibbous moon in the sky. 70% illumination, bright moonlight washes out faint objects. Magnitude 11 comet versus bright moon. Difficult? November 11th. This is the date. Eastern pre-dawn sky. The comet emerges cleanly from solar glare. Constellation Virgo. Positioned near the star Spica initially. Altitude reaches sufficient height 90 minutes before sunrise for telescope users. Minimum aperture 8 inches, 20 centimeters. Magnitude predicted between 11 and 12 depending on activity levels and whether that perihelion brightness surge persists. 8-inch aperture minimum isn't arbitrary. Magnitude 11.5 objects appear as faint fuzzy patches against the sky background. Atmospheric seeing. Light pollution fatigue and the comet's diffuse nature all conspire to make detection harder than spotting a point source, star of the same magnitude. Experienced observers suggest 10-inch or 12-inch telescopes for reliable detection. 300mm aperture preferred. Finder charts matter. The SkyLive published detailed ephemeris, November 5th, 2025. The comet sat in Virgo, November 11th. It remains in Virgo, moving slowly against the background stars. Look for an object that appears fuzzy compared to surrounding stars. The coma spans maybe 4 to 5 arc minutes, visible in telescope eyepieces as extended rather than point-like. Tail may show in long exposure photography. Visual observers likely see just the coma. November 15th and 16th, special alignment. 3I Atlas passes within half a degree of NGC 4691, 11th magnitude barred spiral galaxy. Both objects in the same low-power telescope field. The comet moves visibly against the galaxy over hours. Rare configuration. The galaxy sits relatively close to Virgo's Cup asterism. Moon phases shift favorably. November 9th. The moon was waning gibbous, bright, and interfering. By November 16th, the moon drops to thin crescent, 4 degrees south of the comet, minimal light pollution from lunar glare. November 16th through December 2nd, the moon essentially vanishes from pre-dawn sky. New moon November 23rd. Perfect dark sky conditions for comet observation through late November. The comet's altitude improves rapidly. November 9th, 10 degrees at latitude, 40 north. November 16th, 20 degrees altitude. By December 4th, it rises high enough for comfortable observation, clearing trees and buildings, escaping the worst atmospheric turbulence near the horizon. December 7th through 8th. 3. Atlas crosses from Virgo into Leo, moving through the sky at its hyperbolic velocity. December 12th, it passes near 2 stars in a dim spiral galaxy in Leo. December 19th, closest approach to Earth, 1.8 astronomical units, 268 million kilometers, 167 million miles. Still far, no danger, never closer than that. But by December 19th, the comet fades, magnitude 12.5 predicted. December 30th, magnitude 14, receding from both Sun and Earth, activity declining as solar heating decreases, sublimation rates dropping. Coma shrinking. By year's end, it becomes a challenging target even for large amateur telescopes. December 27th offers one landmark. 3I Atlas passes 1.8 degrees south of Regulus, Leo's brightest star, magnitude 1.3. Easy naked eye reference point. The comet, invisible to unaided eyes, glows faintly in telescopes aimed at Regulus's vicinity. Equipment requirements stay consistent through November and December. 8-inch minimum aperture, 10 or 12-inch preferred, equatorial mount for tracking, long focal length not critical. Comet's coma spans several arc minutes. Medium power eyepieces work fine, 50 to 100 times magnification sufficient. Higher power concentrates light from the diffuse coma into smaller area, potentially improving contrast against sky background. Photography changes the game. Modern CCD cameras and CMOS sensors gather light over minutes of exposure time. Stacking multiple frames cancels noise and reveals fainter details. Smart telescopes with automated tracking and image processing can detect magnitude 13 objects easily. 3-inch to 4-inch aperture, smart telescopes captured 3I Atlas in summer and fall 2025. Those same instruments will work through November. Visual observation remains harder. Human eyes can't integrate photons over minutes. We see what hits the retina in real time. That makes diffuse, low surface brightness objects like distant comets genuinely challenging. Dark sky helps enormously. Moonless nights essential. Averted vision technique where you look slightly away from the object, allowing more sensitive rod cells to gather light instead of central cone cells. Location matters brutally. Light pollution drowns faint objects. Urban observers with magnitude 3 or 4 sky backgrounds won't see magnitude. 11 comets visually. Period. Dark sky sites required. Bortle class 3 or better. Rural areas, far from cities. The comet's low altitude and pre-dawn sky means pointing through more atmosphere and closer to horizon glow from distant cities. Higher altitude observing sites reduce atmospheric interference. The Virtual Telescope Project in Manciano, Italy, scheduled live observation November 17th, starting 04:15 UTC. Robotic telescopes will track and image 3I Atlas in real time. Free public access. International viewers can watch the comet through their screens, while Italian telescopes do the work. Similar opportunities at other observatories worldwide. What makes November 11th special beyond first visibility? That date represents the optimal balance. Solar elongation sufficient? Comets post-perihelion brightness surge still active. Moon phase darkening, altitude improving. Later dates offer better geometry but fading magnitude. Earlier dates mean the comet remains too close to Sun and too low. Observer reports matter. Comet brightness prediction remains imprecise. Outbursts can occur. Unexpected brightening happens when fresh ice layers expose on the rotating nucleus or when subsurface pockets of volatile ices suddenly vent. Fragmentation possible, though. 3I Atlas showed no signs of structural failure as of late October. Each observer who images or measures the comet contributes to the global dataset tracking its behavior. Professional instruments continue coverage. Hubble scheduled ultraviolet spectroscopy observations in November, measuring sulfur to oxygen ratio. Tracking compositional changes as the comet recedes from perihelion. James Webb scheduled additional observations in December, following up on August data, comparing composition before and after closest solar approach, TESS, SWIFT, multiple space assets tasked, Jupiter, icy moons, Explorer spacecraft, JUICE mission. ESA's probe currently on trajectory toward Jupiter. JUICE observed 3I Atlas, November 2nd and November 25th, distance from comet to spacecraft around 64 million kilometers. Much farther than Mars was in October, but JUICE carries sensitive instruments designed for faint targets in deep space. Data transmission rate slow. Observations recorded, but won't reach Earth until February 2026. High-gain antenna serving as heat shield near the Sun forces use of medium-gain antenna at lower bandwidth. Europa Clipper coordination discussed NASA and ESA considering joint observations using twin ultraviolet spectrographs, one on JUICE, one on Clipper, dual spacecraft perspective on the same interstellar object at different viewing angles. Unprecedented opportunity. The science justification runs deep. 3I Atlas, potentially 7 billion years old, formed in the thick disk of the Milky Way, older than our solar system by 3 billion years. The oldest comet ever observed if age estimates prove accurate. Every molecule it vents carries chemical information from its birth system. Star composition, protoplanetary disk chemistry, formation temperature, radiation environment, all encoded in isotopic ratios and molecular abundances. Carbon dioxide dominance suggests formation far from its parent star or in a carbon-rich system. Higher carbon to oxygen ratio in the original protoplanetary disk would produce comets with more carbon-based ices and less water ice. Solar system comets form from our sun's disk, roughly 1 carbon atom per 2 oxygen atoms. 3I Atlas might represent a system where carbon equaled or exceeded oxygen. Different stellar chemistry, different comet composition. Nickel detection remains the headline grabber. Initial observations showed strong nickel emission, but weak iron. Iron normally accompanies nickel in comets because both exist in primitive solar system materials, but 3I Atlas showed inverted ratio. As perihelion approached, the ratio normalized somewhat, temperature-dependent release. Different compounds containing these metals vaporize at different thresholds. The evolution of that ratio through perihelion passage maps the thermal structure and composition of the nucleus layers. Cyanide gas. Hydrogen cyanide production rate doubled in 1 week, September 7th to 14th. Sublimation rate dependent on temperature and freshly exposed surface area. As the nucleus rotates, different regions face the sun. A surface dust mantle erodes from gas pressure, fresh ice exposes underneath. Production rates fluctuate, but the average upward trend matched decreasing solar distance and increasing solar heating. Carbonyl sulfide, sulfur-bearing molecule detected by JWST and other instruments, relatively rare in solar system comets. Its presence and abundance provides another chemical signature of formation conditions billions of years ago. Dicarbon and tricarbon, carbon-2 and carbon-3 molecules, common in many comets producing the green color often seen in cometary comas. 3I Atlas showed almost none. MDM observatory searched. Very large telescope looked. Neither found significant quantities. Upper limit on carbon-2 to cyanide ratio suggests 3I Atlas ranks among the most carbon chain depleted comets known. Another unusual characteristic, amino radicals, molecular fragments containing nitrogen and hydrogen, also not detected in significant quantities. The depletion of certain carbon and nitrogen molecules, while abundance of others like hydrogen cyanide and cyanide gas persists, tells planetary scientists about formation chemistry and subsequent evolution through billions of years in interstellar space. Cosmic ray bombardment. As 3I Atlas drifted through interstellar space for billions of years. Galactic cosmic rays pummeled its surface in shallow subsurface layers. High-energy particles alter ice chemistry, create new molecules, destroy others, implant rare isotopes. The comet we observe now carries scars from eons of radiation processing. Comparing its composition to pristine solar system comets reveals the effects of that processing. Water ice particles, detected by multiple instruments including JWST. Small grains of water ice mixed into the carbon dioxide-rich coma, possibly released when carbon dioxide sublimates and carries water ice grains with it, or possibly from direct water ice sublimation in specific regions of the nucleus. The ratio shifted through the observation campaign. More water detected as perihelion approached and nucleus temperature increased. Reddish coma in July. Hubble images showed red-tinted dust, indicative of fine particles scattering light, similar to 2I Borisov, which also showed reddish color. The color evolved. More intense in July, then shifting as dust production rates and particle size distribution changed with solar heating. Dust tail geometry, pointing away from the sun by radiation pressure. Solar photons hit dust grains imparting momentum. Larger particles deflect less. Smaller particles deflect more. Tail spreads into fan shape. Ion tails separate, driven by solar-wind interactions with ionized gas. Appears straighter and more directional than dust tail. 3. iAtlas showed both in images from ground and space-based observatories. Non-gravitational acceleration, jets of gas escaping from the nucleus act like tiny rocket engines. Pressure from venting gas pushes the nucleus slightly, changes its velocity beyond what pure gravity would produce. Trajectory deviates from perfect Keplerian orbit. Astronomers measure those deviations to calculate gas production rates and jet orientations. NASA report noted non-gravitational acceleration in 3 iAtlas, expected for active comet, consistent with outgassing observed in spectra. Some observers claimed trajectory shifts suggested artificial maneuvering. Professor Avi Loeb at Harvard published essays exploring that possibility, speculating whether nickel abundance and perihelion timing during solar conjunction indicated technology rather than natural comet. NASA's acting administrator, Sean Duffy, addressed directly, "No aliens, no threat to Earth. Third interstellar comet passing through our solar system. Natural object exhibiting expected cometary behavior. Observations show this is the third interstellar comet to pass through our solar system. Natural phenomena. Misinformation spreads fast when uncertainty exists. Social media amplified claims about motherships, mini probes, hiding behind the sun. Reality offers simpler explanations. Solar conjunction happens because orbital geometry puts comet, sun, and Earth in line. Not because of intent. Any object with 3 iAtlas's trajectory approaching from that direction would experience solar conjunction near perihelion, pure mechanics. Blue color during perihelion. Some reports noted the comet appeared bluer than expected. Dust normally reddens light. Carbon monoxide ionization produces blue emission. Natural comets can appear blue when ionized carbon monoxide dominates the coma emissions. Intense blue could reflect unusually high carbon monoxide concentration, or it could indicate observer bias in image processing choices. Confirming color precisely requires careful spectrophotometry, not available in all observation reports. The observation window matters enormously. 3 iAtlas will never return. Hyperbolic trajectory. Escape velocity exceeded. Inbound speed at Discovery 137,000 miles per hour. Speed increases through perihelion due to gravitational acceleration from the sun. Outbound speed high enough to escape solar gravity completely. After it recedes beyond observable range, humanity will never see this specific object again. Future interstellar objects inevitable. Our solar system drifts through the Milky Way. Other star systems drift elsewhere. Their comets occasionally get ejected by gravitational interactions with giant planets. Billions of interstellar comets probably exist in the galaxy. We discovered 3 in 8 years. Detection technology improves every year. The Vera C. Rubin Observatory commenced operations 2024. Legacy survey of space and time begins. That telescope will detect far more objects far earlier. Predictions suggest discovering dozens of interstellar objects per year, once full operations stabilize. Each interstellar visitor offers a sample return mission without the spacecraft. Chemistry from another star system delivered free to our doorstep for study. We can't yet send probes to other stars. Travel times measure centuries or millennia with current propulsion. But comets from those systems occasionally visit us. Study them intensely while they pass. Extract maximum science from brief observation windows. ESA's Comet Interceptor mission. Relevant, planned launch 20s. Spacecraft will wait at Lagrange point 2. When next interstellar object detected interceptor will fire engines and pursue, match trajectory, fly alongside, deploy sub-spacecraft for multi-angle observation and potentially surface impact. First mission explicitly designed to chase interstellar visitor on short notice. 3 iAtlas serves as rehearsal. Learning what to look for, how to coordinate observations, which instruments provide best data. 3 iAtlas won't wait. November 11th, the window opens. Morning sky, eastern horizon, 90 minutes before sunrise. Constellation Virgo. Magnitude 11 or 12, 8-inch telescope minimum. December offers extension of viewing but fading magnitude. By January 2026, it becomes challenging target even for professional observatories. Amateur astronomers contribute meaningfully. Photometry measurements tracking brightness over time. Astrometry providing precise position measurements that refine orbital calculations. Long exposure, imaging revealing coma and tail structure. Spectroscopy, if equipment permits. The Global Amateur Astronomy Network provides temporal coverage professionals can't match. University and agency telescopes schedule specific observation windows. Amateurs observe nightly when weather permits, providing continuous monitoring. The November timeline, 11th. First good viewing, 15th and 16th. Close pass by NGC 4691 Galaxy, 16th through December 2nd. Moonless pre-dawn skies, 17th. Virtual Telescope Project livestream, 23rd. New moon for darkest possible conditions. Late November into early December represents peak amateur opportunity before magnitude fades below 12 and object becomes too faint for typical backyard equipment. Geographic latitude matters. Northern hemisphere observers around 40 degrees north get good altitude. Closer to equator, the comet rises earlier and higher. Farther north, it remains lower and window shortens. Southern hemisphere observers face different geometry. Comet visible, but requires different timing and different sky orientation. Finder charts specific to observer latitude essential. Planetarium software helps enormously. Stellarium, free and excellent. Set location, set date and time, search for 3i Atlas. Software shows exactly where to point telescope. Weather always the wild card. November brings clouds to many regions. Snow in some areas. Temperature drops make overnight observing uncomfortable. Multiple attempts likely necessary to catch clear skies. Monitor weather forecasts, plan observation sessions when high-pressure systems promise clear conditions. Cold weather requires warm clothing and strategies to prevent dew formation on optics. The scientific return from 3i Atlas observations will publish over years. Initial discovery papers already out. Spectroscopic analyses publishing through fall and winter. JWST data analysis papers coming. Hubble follow-up, observations reporting, comparison studies with 1i Oumuamua and 2i Borisov, age estimation refinements, origin tracing through galactic dynamics, chemical modeling of formation environment, dust grain analysis from collected spectra, nucleus rotation period if measurable, outgassing jet orientations, each research team extracting different insights from the data set, one final number to remember. December 19th, closest approach to Earth, 1.8 AU. The distance matters, because media will report closest approach without context. 167 million miles sounds close. Actually, it's almost twice as far as the Sun. No danger, no special viewing enhancement. By December 19th, the comet has faded to magnitude 12.5. More difficult observation than mid-November, despite being closer. Magnitude matters more than distance for visibility. Perihelion triggered maximum activity and brightness. By late December, that surge fades as the comet moves farther from solar heating. March 16th, 2026. 3i Atlas passes Jupiter at 0.36 AU, 54 million kilometers, closer than Jupiter's major moon Callisto orbits. Juno spacecraft orbits Jupiter. Could observe the comet, but spacecraft low on fuel and has engine issues. Redirection unlikely. If Juno does observe, data would arrive months later. Jupiter encounter provides final gravitational boost accelerating 3i Atlas to higher velocity on its exit from the solar system. After Jupiter flyby, the comet fades permanently from amateur reach. Magnitude 15 by summer 2026, 18 by end of year. Only largest professional observatories can track it. Eventually even Hubble and JWST lose detection. 3. I-Atlas vanishes into the black, carrying with it the chemical secrets of its birth system, now somewhat contaminated by billions of years of cosmic ray bombardment and brief 2025 interaction with our Sun. But the data remains, spectra archived, images saved, measurements recorded. Future scientists will reanalyze with better models, compare to later interstellar object discoveries, extract new insights decades from now as understanding of planetary system formation advances. 3. I-Atlas becomes permanent scientific record, even as the physical object races back into interstellar space, never to return. November 11th, eastern sky, 90 minutes before sunrise, Virgo constellation, magnitude 11.5, 8-inch telescope, that's your window. The third interstellar comet humanity has ever observed. 7 billion years old, older than Earth, older than the Sun, older than anything else we can currently study up close, visiting from another star system, venting nickel vapor at temperatures that shouldn't allow it. Dominated by carbon dioxide in ways our comets aren't. Passing behind the Sun precisely at perihelion in what some see as suspicious timing, but what orbital mechanics predicts for any object approaching from that specific vector. Real, factual, documented. 3 spacecraft at Mars photographed it. JWST measured its molecules, Hubble constrained its size, VLT detected its nickel, not speculation, not social media hype. Peer-reviewed observations from multiple independent international research teams using different instruments at different wavelengths, all confirming the same object with consistent measurements. The mid-November return timeline isn't marketing, it's geometry. Solar elongation increasing post-perihelion, comet altitude rising in pre-dawn sky, moon phase darkening to new moon, peak brightness from perihelion surge. Before distance fades, the object below amateur telescope capability. Everything aligns mid-November. After that, the window slowly closes as magnitude drops week by week. You can see history if you try. The oldest visitor from the deepest cosmic past that our species has ever observed still close enough to spot through backyard telescopes for a few more weeks. After November fades into December and December fades into 2026, the comet recedes beyond reach. Opportunity closes, but not the science. Research continues for years. Papers publish, understanding builds. 3. iAtlas adds one more data point to the growing catalog of interstellar objects. The catalog that will revolutionize planetary science as it expands. The catalog that lets us sample exoplanetary systems without traveling light years. The catalog that 3iAtlas joined on July 1st, 2025, when one white pixel moved wrong against the star field in Chile. 7 billion years crossing the galaxy. One brief summer and fall in our solar system. One mid-November morning, sky opportunity for amateur observers equipped with sufficient aperture, dark skies, and clear weather to point their telescopes at Virgo and search for the fuzzy spot that doesn't match the star charts. That's the timeline. That's the truth. No hype, no aliens, no conspiracy. Just the third confirmed interstellar comet making its closest pass to Earth on December 19th, but offering best visibility mid-November when magnitude peaks and moon phases cooperate and altitude improves, while the perihelion brightness surge still persists before distance and declining solar heating dim the coma below magnitude 12 and push the object beyond the practical range of 8-inch and 10-inch amateur telescopes. The universe sent us a visitor older than our world. We have weeks to look before it leaves forever. November 11th opens the window. Use it or lose it. The comet won't wait and won't come back. Hyperbolic trajectories don't allow returns. This is humanity's only chance to observe this specific ancient messenger from another star system before it races back into the eternal darkness between the stars. Late November sky, cold air, clear night, telescope tracking, eyepiece focused, Virgo low in the east, fuzzy patch against stellar background. Extended, moving slowly over hours, not a star, not a galaxy. Something from far beyond our solar system's edge. 7 billion years old, venting ice that froze before Earth existed. Carrying nickel and carbon and complex molecules that tell the story of a stellar system we'll never visit. All compressed into one pale, fuzzy glow in a telescope field of view, 90 minutes before sunrise, in November 2025. That's 3iAtlas. That's your mid-November viewing window explained without the hype. Factual, researched, documented. The timeline runs now through early December. After that, the comet belongs to the professionals with their massive telescopes and years of follow-up observations. But for a few weeks in November, it belongs to anyone with an 8-inch telescope, dark skies, and the dedication to wake before dawn and point their optics toward Virgo while the rest of the world sleeps. The interstellar visitor passes once. Observe now or never observe. Those are the only options. 3, iAtlas doesn't care about clouds or cold weather or work schedules. It follows its hyperbolic path and mathematical precision. Perihelion happened October 29th. Jupiter flyby comes March 2026. Everything between is the observation window. November represents the sweet spot where brightness and geometry and moon phase all cooperate to provide optimal amateur viewing conditions before inevitable fading begins. Chilean astronomers discovered it, global teams observed it, NASA and ESA tracked it, Hubble and Webb measured it, Mars orbiters photographed it. Now backyard observers get their chance. Mid-November, morning sky. The timeline waits for no one, neither does the comet.